Hello, this is Professor Kuehn, and welcome back to my lectures on space, time, and motion, where we are looking at Galileo's dialogues concerning two new sciences, Day 4. You might recall that in my previous lecture, we were looking at figure 11.3. This is on page 145 in a student's guide to the Great Physics Texts, Volume 2. In this diagram, what Galileo had done was to illustrate that an object which is moving with uniform horizontal motion compounded with naturally accelerated vertical motion, such an object undergoes parabolic motion. If now we jump ahead to the following page, this is page 146. Now what happens is Sagredo and Simplicio begin to critique the theory of Galileo of projectile motion. So let's jump in the middle of page 146, where Sagredo says, I'll read a few short sections here and then I'll comment on them. He says, one cannot deny that the argument is new, subtle, and conclusive, resting as it does upon this hypothesis, namely, that the horizontal motion remains uniform, that the vertical motion continues to be accelerated downward in proportion to the square of the time, and that such motions and velocities as these combine without altering, disturbing, or hindering each other, so that, as the motion precedes, the path of the projectile does not change into a different curve. Okay, so he's stating that he understands exactly what Galileo is saying, and now he's going to criticize it. He says, but this, in my opinion, is impossible. For the axis of the parabola along which we imagine the natural motion of a falling body to take place stands perpendicular to a horizontal surface and ends at the center of the earth. And since the parabola deviates more and more from its axis, no projectile can ever reach the center of the earth, or if it does, as seems necessary, then the path of the projectile must transform itself into some other curve very different from the parabola. So notice what he's saying here. He's saying if you look back at this figure right here, the axis of the parabola, the line BOGLN, must pass through the center of the earth, and the earth is a sphere, right? Now, if for some reason the projectile, once fired, falls downward toward the center of the earth, as he is indicating here, and if it was undergoing parabolic motion, then it could not hit the center of the earth or pass through the center of the earth, even if you were to get rid of the resistance of the earth to things falling through it. In other words, that parabola would not intersect the midpoint or the exact center of the earth. But we would expect that an object like a cannonball or a projectile, would be attracted toward the center of the earth and eventually would end at the center of the earth if it could. And since this parabola does not do so, it has to deviate from this parabolic motion, and so Galileo's theory of parabolic motion is in fact incorrect. It cannot be true. Okay, let me go on to the next criticism. So I want you to think about that a little bit. The next criticism is very closely related to this. He says, this is Simplicio now chiming in, he says, to these difficulties I may add others. One of these is that we suppose the horizontal plane which slopes neither up nor down, think about the plane along which this projectile is moving before it falls off the cliff, which slopes neither up nor down, to be represented by a straight line as if each point on this line were equally distant from the center, which is not the case. For as one starts from the middle of the line and goes toward either end, he departs farther and farther from the center of the earth, and is therefore constantly going uphill, whence it follows that the motion cannot remain uniform through any distance whatever, but must continually diminish. Okay, so that's one criticism. And then he says, besides, I do not see how it is possible to avoid the resistance of the medium, which must destroy the uniformity of the horizontal motion and change the law of acceleration of falling bodies. These various difficulties render it highly improbable that a result derived from such unreliable hypotheses should hold in practice. So notice what he's saying here. If you look at this plane, the line AB, well, that's supposed to be a horizontal plane. But if you think once again that the earth is a sphere, then as it moves along a horizontal line, it has to be either going uphill or downhill. So if you think about the line BOGLN, if that one pointed straight to the center of the earth, then as it's going from A to B, technically speaking, it's going downhill. It's getting closer to the center of the earth. And if that plane continued forward along BCDE, then after point B, it would be getting farther from the center of the earth. So the horizontal line is really tangent to this sphere, you might say, or a little bit above this sphere. but it's getting farther and farther away from the center, the more distant it gets from a radial line starting at B and going to the center of the Earth. So that's a criticism that's related to the previous criticism that Sagredo brought up. What's the other criticism that Simplicio brings up? He brings up the idea that he doesn't think the assumption of uniform horizontal motion after it falls off the cliff is correct. Why is that? Because there's air resistance or drag, so it doesn't undergo uniform horizontal motion. And insofar as this proof relied on the idea that it undergoes uniform horizontal motion in the derivation of the parabolic form, therefore it cannot be having parabolic motion. Okay, so let me sketch out or summarize these proofs. I'll just write them down. If you look over here at my sketchbook, okay, so what are the problems? First of all, he says in figure 11.3, I'm going to put these in my own words and kind of summarize what I think are the main points. In figure 11.3, and this captures, I think, the first two criticisms, the vertical lines, which are these vertical lines starting at B and going down, or C and going down, and D at going down, and so on, which denote the direction of uniform acceleration. After all, it's uniformly accelerating in the vertical direction. These are parallel, right? At least in the drawing, they're parallel. But in reality, the Earth is curved, right? So these lines along which this uniform acceleration happens cannot be parallel. Right? So they really, if you kind of were to zoom out here and think about the Earth, here's the center of the Earth, and here is the Earth. That's not really the center of the Earth in that picture. Let me redraw that. Here's the center of the Earth. The lines along which uniform acceleration would happen would be tilted toward each other. And so if you think about this cliff here, as the ball goes off the cliff and it accelerates downward, these vertical lines are actually tilted inward a bit, which is not captured in figure 11.3. And insofar as this proof relies on the idea that the vertical direction is the direction of uniform acceleration, insofar as the proof relies on that, this proof isn't reliable because those are actually not parallel lines. How does Galileo address this? Because technically it's correct. So if we jump ahead to the next page, 147, he says, all these difficulties and objections which you urge are so well founded that it is impossible to remove them. And as for me, I am ready to admit them all, which indeed I think our author would also do. So first of all, he says, you're right, these are difficulties, okay? And he says, I grant that these conclusions proved in the abstract will be different when applied in the concrete, and will be fallacious to this extent that neither will the horizontal motion be uniform, nor the natural acceleration be in the ratio assumed for the path of the projectile, a parabola, etc. But on the other hand, I ask you not to begrudge our author that which other eminent men have assumed, even if not strictly true. So he's saying technically you're right. The first problem that you just mentioned, that these lines are not parallel, or that the Earth is curved and that has effects on this, that's a perfectly valid criticism. And also the assumption that there is no drag, and so you have uniform horizontal motion, that's not quite right either, okay? But hear me out, he's saying. In practice, our instruments and the distances involved are so small in comparison with the enormous distance from the center of the Earth that we may consider a minute of arc on a great circle, that is a very small angle, a minute of arc on a great circle as a straight line, and may regard the perpendiculars let fall from its two extremities as parallel. He says that if you're considering a huge circle like that of the Earth, think about an enormous circle, and if you're considering a very small angle like this, then that curved line is just about a straight line. If this is a very small angle, that's just about a straight line. And we may consider it to be a straight line. And the lines perpendicular to it, we may consider, at least over some small range, we may consider them to be parallel. He says, for if in actual practice one had to consider such small quantities, it would be necessary, first of all, to criticize the architects who presume, by use of a plumb line, to erect high towers with parallel sides. Okay, so think about when people are building houses. What do? They hold what's called a plumb line, which is a heavy bob, a heavy metal object on the end of a string. They hold it up and they say, we're going to build a wall that is along this plumb line. And then they go to the other side of the room and they hold the plumb line and they put another wall over there. And they say those two walls are parallel. Now, technically speaking, they're not exactly parallel because after all, when you walk across the room and you hang the plumb line, that line is technically not exactly parallel to the first line because you moved over a little bit and they're both pointing toward the center of the earth and the earth is curved. So strictly speaking, those two walls are sloping out from each other a little bit. But it's such a small effect that in practice, they're parallel. That's the point he's making. So if you're going to criticize what I'm doing here, you should really criticize architects who are building buildings with parallel walls under the exact same assumption that I'm using. By the way, this is an interesting topic. This is one of the criticisms of people who are flat earthers, so who believe that the earth is in fact flat. If you look at some of their arguments, they will show pictures, for example, of the Golden Gate Bridge in San Francisco. And they'll say if the earth was curved, then the towers of the Golden Gate Bridge should be sloped outward a bit like this. But if you look at them, they're straight up and down. And that implies that the earth, in fact, is flat, not curved, like they suggest. Okay? I'll leave it at that. He goes on to say, I may add that in all their discussions, Archimedes and the others considered themselves as located at an infinite distance from the center of the earth, in which case their assumptions were not false, and therefore their conclusions were absolutely correct. When we wish to apply our proven conclusions to distances which, though finite, are very large, it is necessary for us to infer on the basis of demonstrated truth what correction is to be made for the fact that our distances from the center of the earth is not really infinite but merely very great in comparison with the small dimensions of our apparatus. Now, how does he treat of the second problem? He says, as to the perturbation arising from the resistance of the medium, so this is the effect that drag has on the moving object so that it's not going with a uniform motion. He says, as to the perturbation arising from the resistance of the medium, this is more considerable and does not, on account of its manifold forms, submit to fixed laws and exact description. Thus, if we consider only the resistance which the air offers to the motion studied by us, we shall see that it disturbs them all, and disturbs them in an infinite variety of ways, corresponding to the infinite variety in the form, weight, and velocity of the projectiles. So strictly speaking, the problem of air drag is a very difficult problem to account for. And in his proof, he assumed that there's no air drag. But if you do have air drag, then to try to account for that is challenging, and it does make it deviate from parabolic motion. But the specific way that it deviates from parabolic motion depends on the shape and the size of the object, the type of the medium, in fact, even how fast it's going. So that this topic is an extremely complicated topic, and he says it will take a lot more sophistication to try to deal with this.